So as Charlotte said, I'm Holly Pearen. I'm a senior attorney on the oil and gas team at the Environmental Defense Fund. EDF is an international environmental nonprofit with about 1 million members worldwide. And we're science-based and, where possible, advocate for market-based solutions to environmental problems. My area of focus is oil and gas, and this presentation will cover a brief overview of the risks associated with reuse of produced water and emerging regulatory responses. There are big opportunities here, and with that come some fairly significant risks as well. Reusing oil and gas wastewater makes a lot of sense in theory. We produce 800 billion gallons of wastewater from oil and gas operations every year. And in some arid parts of the country, recycling the wastewater could reduce pressure on freshwater sources. But this comes with a big caveat. Recycling itself isn't easy, and it doesn't always make economic sense, and it's certainly not risk-free. So before we jump into infrastructure and systems that incentivize recycling, we need to make sure we're not causing more problems than we solve. There are two sort of big categories of risks associated with recycling that I'll introduce today. The first is risk of spills and leaks of minimally treated water. And the second is uncertainty about the constituents in the wastewater, how to analyze them, how to treat the constituents, and how toxic they are to humans, aquatic, and terrestrial systems, like plants, bugs, and soil. So the risks of spills and leaks at the surface are significant, and we're really not solving water shortage issues if we contaminate existing sources. A GWPC study released in 2012 indicates that spills at the surface cause 70% of the groundwater contamination associated with oil and gas production. Because recycling entails more intensive handling of wastewater, the risks of spills and leaks are also greater than simple disposal. It just means that you're handling the water more, storing it in larger volumes, and transporting it more. And then I think it's important to note that reuse within the field usually entails less robust treatment than for other potential reuses. Increasingly, operators are able to use higher TDS water in their base and makeup fluids, and it's not cost-effective to fully treat wastewater before transporting and reusing downhole. And that makes sense, but it also means that the wastewater will still contain many constituents that could be damaging if spilled or of unknown toxicity. And so this risk isn't speculative, right? The amount of wastewater spilled from oil and gas operations is increasing, even though production is declining. Even though spill data is incredibly difficult to obtain, the states that do collect and make transparent their records show more and more spills. Data compiled by EE News shows that the national spill rate increased in 2013 by 17%. And the New Mexico Legislative Financial Services compiled data for the state of New Mexico in 2014, and their data showed that the volume of wastewater and fluids associated with oil and gas operations increased by 61%, while the rate of oil production increased 23%. And I think part of this could be explained by the increasing trend to keep water at the surface longer and move it around more, which creates opportunities for leaks and spills and tanks and pipelines and pits. So states have responded to the demand for recycling with new regulations that make it easier to reuse water. This first wave of recycling regs streamlined permitting for pits, tanks, and recycling facilities, which is somewhat counterintuitive if you're worried about leaks and spills without good enforcement and robust requirements initially for design and construction. States like Texas and New Mexico passed rules that specifically encourage recycling and make it easier to do by authorizing it and approving certain infrastructure if it meets certain specifications. And I'll note that North Dakota, Ohio, Colorado, New Mexico, Texas, they all have rules that specifically apply to saltwater, produced water, or recycling facilities. But I'll use Texas as an example. It was the first recycling rule per se, and it's been somewhat of a template for the recycling rules that followed. And under Rule 8, you don't need a permit to construct a pit used in recycling operations as long as the pit meets certain standards. It must be lined, You must have 2 feet of freeboard. Single-line pits must be emptied annually and inspected, or you can use a double-lined pit with leak detection, among a couple other things. And these are fairly good. Leak detection and repair and inspection, particularly on a regular basis. Fairly good regulations, and streamlining the regulations as these rules do isn't necessarily bad per se, but it does make enforcement and ensuring rules are followed even more important to ensure that pits and tanks used to store this minimally treated water doesn't leak out onto soil and waterways. Another emerging trend is a set of specific regulations pertaining to pipelines that transport oil and gas wastewater. North Dakota's legislature just passed a bill last session, HB 1358, requiring operators of buried wastewater pipelines to submit a bond and certain maintenance, operation, construction, and design information to the NDIC. They also directed EERC, the University of North Dakota's research arm, to study wastewater pipelines and the cost efficiency of leak detection and repair. And that report was published last week, and I'd encourage you all to take a look at it. They did a good job. And another pipeline regulation that we might see emerge is in Pennsylvania. Their DEP included pipeline regs in the draft Chapter 78 rules. And those draft rules contain a lot of really interesting protective conditions, such as daily inspection while the pipeline is in service, and shutoff valves that would limit spills to 1,000 barrels. And the other big area for reuse of produced water, or I should say interest in produced water, at least in the West right now, I know Jeri will talk about some other non-traditional uses, is reuse for things like de-icing, agriculture, and wildlife. Some of this is facilitated in the West by an exemption to the statutory prohibition on discharge of oil and gas wastewater as 40 CFR 435 subpart E that allows discharge of wastewater west of the 98th meridian if the water is of good enough quality for agriculture and wildlife. And that's a direct quote from the regulations, of good enough quality for agriculture and wildlife. The problem is how to define what good enough means. The regulations governing water quality and health don't cover many of the pollutants found in oil and gas wastewater. This is the fundamental problem. Our water quality and drinking regs don't fully overlap with all the constituents that you may find. A couple things explain this. First, current EPA analytical methods don't perform well in high TDS environments characteristic of oil and gas wastewater. And they don't necessarily detect at very low levels in those environments, even though some of the constituents can be toxic at very low levels. So measuring the constituents is difficult. Second, EPA in their I usually say hydraulically fracturing, and I'm trying to think of a more technical or politically appropriate term, but in their drinking water assessment, said that we lack chronic toxicity data for 80% of all the 1,100 pollutants that may be found in oil and gas wastewater. So we really only understand the effects of 20% of what's in the water, and not always the full chronic toxicity, right? Such as the effects on plants, soils, or aquatic ecosystems. According to our analysis of the 134 chemicals identified by EPA's drinking water assessment as being present in oil and gas wastewater, less than half, 60, are on the priority pollutant list, which forms the backbone of many environmental protection regulations on average. Less than 30 are contained in NIPD's permits, typically issued for industry facilities. And less than 20 are on the effluent guidelines for centralized wastewater treatment facilities, the commercial treatment facilities that typically receive oil and gas wastewater. Irrigation or agricultural water quality standards don't address these oil and gas constituents either. And so typically, standards published by FAO, USDA, and Extension Services address TDS through chlorides, SAR, EC, and general water quality parameters like pH, boron, and nitrate concentrations, and a host, about 20 inorganic constituents based on observed phytotoxicity. These are some of the examples you might see. There's a real gap here in the research and standards. There's an immediate need for additional research into chronic toxicity of many of the constituents found in produced water, and not just for human toxicity. Plant, soil, terrestrial ecosystem impacts, how some of these constituents persist in soils and sediments, bioaccumulate, and their effects on bugs and fish, and fate and transport generally in the environment is critically important to inform beneficial use. And this is particularly important now and emerging now because previously the salt content alone of many of these alternative water sources would knock those sources out of contention. But current treatment capabilities are becoming more economically feasible, and the TDS can be removed, but many constituents may remain. And those remaining constituents may or may not have known toxicities, and may or may not, but most often do not, have regulatory limits. The state regulations governing this particular beneficial use of produced water outside the oil field is really another unknown in many places. Because this is a new process, there really isn't a clear path to permitting or regulation in most states. And it can involve many agencies that are different in different states. But in general, you're probably touching on the jurisdiction of 3 or 4 agencies. First, the oil and gas agencies that govern oil and gas activities and E&P waste, which produced water is considered. And your oil and gas agency will govern things like pits, tanks, drilling, disposal options, infrastructure, things like that. The state environmental agencies with primacy, or EPA in some states, regulate discharges of pollutants to surface waters of the state, and therefore may be involved in determining protective application levels and treatment standards. And the waste divisions, or these might be contained in the environmental agency or in a health department, govern waste handling, disposal, and classification, and may have a specific beneficial use program for RCRA substances that could be expanded or massaged to include this category of reuse. And finally, some states, particularly in the West, have an agency to administer water rights, which would govern the type or types of uses to which the water may be put, and how and whether the water can be transferred and owned. And this isn't necessarily a government regulation yet, but another legal concern that may influence beneficial reuse that could be covered by statute, but may also be defined in case law, is the state's tort liability framework. And you know, despite some of the unknowns, based on demand, some states are forging ahead with regulations that specifically address recycling and reuse of produced wastewater. As I mentioned earlier, Texas's Rule 8 was the first to address recycling. And Rule 8 specifically encourages recycling of produced water, allows it in the field for downhole uses without a permit, and also authorizes the use of distilled water for any purpose other than discharge into surface waters, and uses permitted by another state or federal agency. Other than reuse downhole, reuse of distilled water, and reuse under another permit, additional uses may be permitted on a case-by-case basis by the Railroad Commission. The RRC issued their first recycling permit for the Pecos pilot project, and Jeri will cover in detail. The permit addressed some of the spill risks by limiting the amount of water that could be stored on the site at any one time, 1,000 barrels of untreated water and 3,000 barrels of treated water, and also prohibited runoff from the facility after application. And as for water treatment and quality, the permit delegated the specifications to the irrigator researchers, who are terrific. By the way, Katie Lewis is doing really interesting work here. And the list of analytes that Texas A&M tested for is up on the screen. And I understand that the main limitation on this analyte list might have been funding. They had no outside funding for this. So there's a real opportunity to expand research in this area to evaluate things like organics or perhaps a whole effluent toxicity analysis. New Mexico's rule is very similar to Texas's Rule 8. The Oil Conservation Division in New Mexico passed a rule last March that encourages recycling similarly and streamlines permitting and regulations pertaining to recycling and recycling infrastructure. New Mexico's rule authorizes by rule recycling for downhole uses and states that other uses will be permitted after a case-by-case evaluation. The rule also specifically calls out pilot projects with favor, I would add, and will allow these after review by the division. So clearly they're forward-looking in this regulation. Wyoming is a great example of how these states are addressing this potential reuse very differently. Wyoming's Department of Environmental Quality issues permits for discharge to the surface that consider the subsequent beneficial use. So Wyoming has a long history of discharge of oil and gas waste based primarily on the prevalence of coal bed methane wastewater in the Powder River Basin. However, DEQ also has a specific permit application that addresses discharges of other types of oil and gas wastewater. As part of the application to discharge to surface waters, new applicants have to certify that the water will be beneficially used for agriculture or wildlife. Part of the permit analyte list is copied here. Applicants for this permit must test their discharge and keep it below these established limits, which I'll mention don't necessarily include some of the things we would expect to find in produced water. These are three good examples. They're obviously not all of the states that are dealing with this, but I can answer specific questions if you have them later. So after identifying some of the risks and the regulatory responses, I think the takeaway is really to proceed with caution on this one. Regulations in many states lay the foundation for recycling and beneficial use of produced water outside the oil field, or at least projects that will explore this potential reuse. The question is, will the permits and the regulations, the new regulations, contain terms and conditions that are sufficiently protective of human health and the environment, even though it's still unknown exactly what pollutants are in the water, how they can be tested and treated, and exactly how toxic the constituents may be to humans, plants, soils, and aquatic ecologies. I want to clarify that recycling and reuse does show a lot of promise in theory, and the purpose of regulations really isn't to obstruct this potential, but it's essential to proceed with caution because we're only going to exacerbate water shortages if we pollute existing freshwater supplies, and we certainly don't want to trade one environmental problem for another by moving too quickly. And I'd be happy to answer questions afterwards.